In this example, we're going to find the equation for tangent lines to specific points along a parametric curve. And here, we're going to actually find the equation of two tangent lines. This just happens to be the problem. Two tangent lines to the point 3, 0 along the curve x equals t squared and y equals t cubed minus 3t. And the first thing we might notice is, well, we're asked to find the equation for a tangent line. And let's just remember the two possible ways to write lines. There was the slope-intercept form, which is y equals mx plus b. So if we wanted to define a line using this, we have two unknowns, the slope and that y-intercept that we need to figure out, and then we have an equation of a line. And there's the other formulation, the point-slope formula. And this form might be a little less familiar to us, but let's just check it out. This is y minus y0 equals the slope m times x minus x0. And let's just make sure we're on the same page. M, that's still our slope. That's the slope of the line. Y0 and x0, well, this is a point along the line that we're finding the tangent line to. And you might notice in this example, we were given right from the start, hey, we want to find the tangent line to a specific point 3, 0 around that line. And in fact, this point-slope formula, this is going to be the more useful formula for us for finding tangent lines. Because as long as we can identify a point along that curve that we care to find the tangent line to, we just have to find the slope, and then we have the equation of a tangent line. So just to be clear, in this example, our x0, that's equal to 3. Our y0, that's equal to 0 because we care about the point 3, 0. So if we just plug in that information, we have y minus 0 equals that slope that we still have yet to have found times x minus 3. So we're almost there in terms of finding our tangent lines, except we still need to find the slope. So in the couple videos ago, we figured out how to find the slope along a parametric curve. The slope we still think about as dy dx, basically rise over run. And for a parametric curve, we saw that this is equal to, well, dy dt all over dx dt. And just so we're on the same page from earlier, well, we wanted to take a derivative of what we had for y. Our function for y was t cubed minus 3t. Our function for x was t squared, so let's just plug those in. So we're taking a derivative of y, which is t cubed minus 3t. And we divide that by the derivative of x with respect to t, which was t squared. So when we just go ahead and do that, we find that the slope dy dx is equal to 3t squared minus 3 all over 2t, which we could simplify to a 3/2 times t minus 1 over t. And at this point, we have a formula for the slope. In that formula, what we need to do is figure out what t value to put into that slope. Well, in this problem, we're not told a t-value. What we're told is the 0.30 along the curve. So what we need to do is extract the t-value that lands us on that point on the curve. So we're going to try and use what information we have from this problem to figure that out. And in this problem right now, we know, well, at this point on the curve, x equals 3 and y equals 0. The other information that we're given is, well, we know an equation for x and we have an equation for y as well. So if you remember, our equation for x was x equals t squared. And if we care to land at the point 3, we need t squared to equal 3. In terms of y, we are told that y equals t cubed minus 3t. And we need that whole thing to be equal to 0. So hopefully you might start to get a sense of where we're about to go. We can take our equation for x and our equation for y and set them equal to the point that we care x is equal to and y is equal to, and find what t-values work. So for example, if we solve this t equation for x, we get from the left-hand side that t must equal plus or minus the square root of 3. If we solve this equation for t cubed minus 3t equals 0, we get t cubed equals 3t, which one solution already, t equals 0. Could actually do that another way. For example, we could have taken out right from the start a t from both terms. So we have t times a t squared minus 3. And if the product of two things equals 0, then one or more of those things have to be 0. So we can find that, hey, t equals 0 is a solution. And we find that t has to equal plus or minus the square root of 3. Again, setting t equals 0 and t squared minus 3 equals 0. And when we compare both sides, as in we have solutions t equals plus or minus root 3, t equals plus or minus root 3 for y. So it looks like when t is equal to minus square root of 3 and plus the square root of 3, or just square root of 3, we land at that point 3, 0. Well, t equals 0 lands us at y equals 0, but t equals 0 does not land us at x equals 3, so we can just throw that point away. So now what we need to do is just plug these t values into our slope. And then we can get the two equations of the tangent lines we care about. So let's plug in first t equals square root of 3. Well, we had that dy dx a moment ago. We saw was equal to 3 times the quantity t minus 1 over t. And if we just plug in what we found for t, that is square root of 3 plus 1 over square root of 3. So we have the slope there, and then we can just take that slope and plug it into our point slope formula. So what was previously that unknown m is now 3/2 times the square root of 3 plus 1 over the square root of 3 times the quantity x minus 3. And that is one tangent line. Oops, I made a sign error. That should be copying from the previous page wrong. Square root of 3 minus 1 over the square root of 3. Square root of 3 minus 1 over square root of 3, excuse me. Copying error. And if we plug in t equals minus root 3, we first calculate that slope of the derivative, dy dx is equal to 3/2 times minus square root of 3. We'll get a plus because the minuses will cancel out. 1 over square root of 3. And then we can plug that into our tangent line formula. So as previously, that m is now 3/2 times the quantity minus square root of 3 plus 1 over square root of 3 times x minus 3. So we have our two equations of a tangent line. And just to walk us through that entire problem again, we were originally interested in finding the tangent line to a specific point along the curve. And we were told, hey, you know what? Actually find two tangent lines. From there, we talked about how the point slope formula of the line would be more useful for these types of parametric curve problems because we know the point in which we're plugging into this point slope formula. We know x is 3, we know y is 0, so the only thing we had to do left was calculate that slope. So we calculate the slope using the parametric curve slope formula. dy dx is equal to dy dt over dx dt. Took all those derivatives, figured out, hey, now we have a formula for slope. The only thing was we need to figure out what t values to put into this derivative. So to figure that out, we knew what information we had at hand. We knew the point along the curve, that in this case it was 3, 0, and we know the curve itself, x and y. So we could set the x equation equal to 3, the y equation equal to 0, and figure out what t values land us at x equals 3 and y equals 0. And the t values that agree for both x and y's were the t values that we could find tangent lines for. So we plugged in those t values into our tangent line slopes, and then just plugged whatever we found for the slopes into our actual tangent line equation.